Good afternoon. I am Wesley Stine. I am currently a master's student at Purdue University, and today I will be presenting Project Menegroth, my plan for a 1,000-strong subterranean Martian colony. The multitude of technical and human challenges of living on Mars can best be met by building the colony in a natural lava tube, sealed and filled with air. On Mars, the full force and ingenuity of modern technology is going to be needed to eke out the barest level of subsistence. Agriculture be a great challenge. Fabrication of machines and other resources, also a challenge. Mining, a challenge. I will discuss all of these. I'll also discuss economics. Trade with Earth will be necessary, and Martian exports will include precious metals, scientific research, and intellectual property. You can see the basic plan of the cave habitat in this diagram. There will be a main entrance on one side. There'll be an industrial area, a residential area, and at the bottommost part of the cave, a large subterranean lake with a reactor. This will be built in a flat-bottomed lava tube. There are many benefits of living in a lava tube. Little work is required to construct it. You simply need to seal off any weak points and build an entrance and fill it with air. You'll have a city-sized inhabitable volume. No need to go through airlocks when passing from one building to another. You'll also have protection from radiation. If, for instance, the colonists spend 2/3 of their time in the city, then they'll have only 1/3 the radiation exposure as if they had built their shelters above ground. I think it'd be foolhardy not to use this resource that nature has already provided. It will be a flat-bottomed lava tube, about 2 kilometers long and 120 meters wide. We know from satellite imaging that lava tubes exist on Mars. Unfortunately, the only kind that you can see is the ones where the roof caved in, so you can see the skylight. This will have to be built in an intact lava tube. The site selection, it'll have to wait until we already have boots on the ground and human exploration of Mars to find a suitable site. The main street of this city will run from the entrance at the front of the tube to the lake at the back. The lake and the nuclear reactor are the heart of the colony. They provide power and thermal stability to the rest of it. Atmospheric pressure inside is 20 kilopascals. Composition 75% oxygen, 25% nitrogen. That 15 kilopascals of oxygen will give you about the same amount of breathable air as in a high-altitude city on Earth. Mexico City or Addis Ababa are good analogs. Demographics. Of the 1,000 inhabitants, I estimate that about 300 will be children under the age of 16. Of the 700 adults, you'll have about 200 machinists, 200 miners, 50 who work in the foundries, 30 work in the greenhouses, 20 work at the reactor, and 200 work elsewhere. The other professions, too numerous to list, but to begin with, you'll have scientists, educators, physicians, diplomats, merchants, artisans, shopkeepers, and cooks. The residences will be fairly simple, a minimalist aesthetic, as you won't be spending much time at home. You'll be quite busy. I expect they'll be about 3 stories high, fairly small apartments. But surrounding these residences, you will have gardens, parks, chapels, schools, restaurants, and other buildings. The inside of the cave will be lit to about 2% or 1% of noonday intensity, so well enough to see as if it were dawn during the daytime. You don't have enough power to light it to full intensity. And the roof of the cave will be painted like a sky on Earth, with figures of gods and heroes soaring above to make it beautiful. The nuclear reactor provides the main power source. You're going to have to rely somewhat on solar power. You'll have to have solar panels to provide rudimentary power before you can power up the nuclear reactor when first constructing the colony. However, the main source is the reactor, and only after the reactor is powered up can you operate the full industrial plant. I've estimated you'll need 33 megawatts of electric power. That's 33 kilowatts per capita. The way I arrived at that is I compared the most energy-intensive country on Earth, which is Iceland, 5.7 kilowatts per capita. And the reason they consume so much is they do a lot of aluminum smelting. That's their main industry. However, in Iceland, only 1 out of 6 workers is in heavy industry. In Menegroth, it'll be almost all of them, so I multiplied that by 5 to get your 33 megawatt requirement. And you'll use an integral molten salt reactor that is a design currently under development by the Canadian firm Terrestrial Energy. It's a liquid core reactor, operates at atmospheric pressure, hence no risk of explosions and no risk of meltdown as the core is already molten. So you're going to need a climate control system within the cave. The lake is the heart of it. The lake is always kept at 25 degrees centigrade. A strong wind will blow from the lake to cool all of Menegroth. Warm air from the industrial region is piped back and bubbled up through the bottom of the lake to return everything to 25 degrees. All of the power, the 33 megawatts electric and the 47 megawatts of thermal waste heat, is all going to get eventually returned to the lake in the form of heat, whether that's direct from the reactor or waste heat from industrial processes. I think that the only practical way to cool this lake is to allow some of the water to boil off into the Martian atmosphere for evaporative cooling through a system of pipes. That's going to be 2,500 tons of water per day. You'll have to add 2,500 tons of ice each day. I think this is certainly achievable. As the number one mineral resource will be ice, you'll build this colony right next to a suitable ice deposit. Next, foundries and machine shops. There's going to be a lot of need for manufactories on Menegroth. Ore is going to be smelted in the foundries to make iron, aluminum, copper, and other metals. The machine shops that work with these metals are going to need to use CNC milling, PLC controllers, and 3D printing in order to operate with only a small number of highly skilled laborers multiplying their power through these machines. The manufactories are going to need to produce vehicles, spacesuits, spare parts for all the machines, for life support machines, for machining machines. You'll need to produce clay, brick, and glass for construction. You'll also need to produce industrial and agricultural chemicals, everything from fertilizer to explosives. As for metalworking, your principal metals are going to be iron and aluminum. Secondary importance is going to be copper, nickel, zinc, and uranium. Iron is going to be a challenge because steel making on Earth relies on coal. On Mars, there is no coal. You'll have to use hybrid technology, which is hydrogen smelting. It's currently under development for decarbonization purposes. You'll produce hydrogen by electrolyzing water at the reactor. Aluminum is easier to smelt because of its lower melting point. It's smelted on Earth through electrowinning. It can be smelted through electrowinning on Mars. Metals are going to be machined both subtractively with 3 and 5 axis CNC mills and additively with 3D printers. Pictured is the Super Draco thrusters, all 3D printed. So if you can 3D print a rocket engine, you can 3D print nearly anything. I've assumed that about 1,000 major machines are going to be needed. That's 5 major machines per machinist, but only 20% of them are going to be brought whole from Earth. For the others, you only bring the fine components, the electronics, tool heads, motors, and manufacture the coarse components in place. In addition to metals, you're also going to work with ceramic and organic materials. Ceramics are abundant. There's lots of sand and clay on Mars. So you'll be able to make glass, brick, and other ceramics easily. You'll use these for industrial purposes in kilns, for instance, also for agriculture to build the concrete bases of the greenhouses and the glass roofs of the greenhouses. Organic chemicals, on the other hand, are going to be scarce. It takes a lot of energy to make long hydrocarbon chains without a petroleum feedstock, so you're going to have to use these sparingly. Still, you'll need a little organic material to make plastics and textiles. Agriculture and greenhouses. I expect Menegroth to require 45 hectares of agricultural land. That's going to be provided by 30 greenhouses, each 50 meters wide, 300 meters long. The greenhouses are built on the surface of Mars. They'll be reached by small pressurized rovers each workday. They'll be lighted with natural light. Lighting them artificially would require more power than we actually have. We will not build the greenhouses until the other industries are well established and can produce sufficient glass. It's going to be more important to get the industrial plant up and running. You can bring enough food for the first 5 years for only $500 million in shipping costs. As long as it's dehydrated, you mix it with water on Mars. Soil for greenhouses is going to be created by washing Martian regolith to leach out toxic perchlorates, and then adding fertilizer, microbes, dung, and worms to sustain plant life. The growth of food crops in such a soil under Martian lighting conditions has been demonstrated in the pictured experiment at Villanova University. The staple crops for Menegroth will be wheat, sorghum, amaranth, potatoes, maize, and beans. All of these are high-calorie, protein-rich crops. Under ideal conditions, Earth-like growing conditions, the population could live on 8.4 hectares of farmland. They're going to need a large safety factor, however. I've estimated a safety factor of 2.5 because you're going to be working with poorer soil and less light. So then you need 21 hectares for staples. I estimate you'll need another 24 hectares for non-staple crops, fruits and vegetables, for instance, as well as non-foods, hemp, cotton, and so forth. So you'll need a total requirement of 45 acres. If this was purely about economics, you'd want everyone to be a vegan. However, there's other benefits for raising a small number of animals. Science and companionship as well. You'll raise goats, chickens, and rabbits. You'll only eat their meat at feasts. You won't eat meat every day. You'll also get milk from goats. Cats, dogs, and birds will be kept as pets. Mice can be kept for research. If you throw agricultural waste, straw and such, into the lake, you can feed an ecosystem of fish as well. I'll next discuss minerals and mining. The most important mineral resource for Menegroth is going to be water ice. After that, base metals, chiefly iron and aluminum, are going to be mined in smaller quantities, and precious metals will be mined for export. Menegroth's site can only be chosen after Mars has been explored for minerals and suitable deposits have been located. I also think that because of the importance of finding and exploiting mineral deposits, the most important science to Menegroth will be geology. Geologists will become some of their most valuable citizens. There's going to be two methods of mining that you use here. One is rail mining. You basically run rail lines from the front of the colony to the deposit. Miners sleep safe in their homes in the cave, go to work every day on the train. They have plenty of electrical power from the reactor. And this is how you'll mine the ice, the iron, the aluminum. Convoy mining is going to be the difficult method. You'll have a pressurized rover with perhaps half a dozen miners in it, escorting a convoy of perhaps a dozen semi-autonomous unmanned mining machines. They'll go out on a journey of a month, maybe 2 months, maybe 3 months into the Martian wilderness to search for rare metals. This is going to be slow because you have to use solar power, so you won't be able to go hundreds of miles a day. I think at most you'll go 40 kilometers in a day on your solar power. It'll be dangerous. You'll be away from home for months at a time. You'll have to be very resourceful. Teenage miners are always going to start their careers at the rail mine sites. Only the bravest and most resourceful of the colonists will want to become convoy miners and make those perilous many-month journeys in pursuit of gold, silver, and other rare metals. I'll next discuss the economy of Menegroth. This colony can only be built after the establishment of routine interplanetary flight with the shipping costs 500 kilograms to Earth, 200 kilograms back. Once that system is in place and interplanetary flight is safe and routine, I estimate the cost of construction for Menegroth at $15 billion. That's $1.5 billion for the nuclear reactor, $500 million for food, $2.3 billion for manufacturing equipment and machines, $2.8 billion for the mining machines, and then I put $7.9 billion, or a little bit more than that, for contingency funds for all the things that you'll need that are too numerous to name, spacesuits and everything else. During the early years, Menegroth is going to have to rely on settlers, levies, and corporate sponsorship to defray the cost of operation before it becomes profitable. Now I'll discuss imports and exports. Menegroth is always going to have to import some things. You can't build a fully self-sufficient colony with 1,000 people. You're going to have to import integrated circuits, other fine machine components with supply chains involving millions of people that you can't manufacture locally. You'll also have to import intellectual property. Mars will consume, as well as producing intellectual property, the software, the designs that all of these autonomous machines run. It's going to be, in many cases, proprietary. It took thousands or millions of people on Earth to develop these programs. They're going to need to be compensated. To pay for these imports, you'll want to export both physical and intellectual property. For intellectual property exports, you'll want both scientific research and entertainment media. There already is a well over $1 billion a year industry of scientific research into Mars. You have universities doing research on Mars, governments doing research on Mars. Once a city is built on Mars, most of that research is going to go through that city. People on Earth, researchers, will hire Menegroth's colonists to collect rock samples or drill a borehole, search for life, or do whatever other experiment needs to be done. As for physical exports, it'll mostly be limited to precious metals once the novelty of Mars rocks is worn off. Gold, I believe, will be the most important, as gold on Earth, it's fairly widespread. You can find it on every continent. Platinum, palladium, there's other precious metals just as valuable, but they can often be found in only one country. So I'm predicting that gold can be found in every region of Mars. If you find the others, you should use them, but gold is the one you can rely on. Now I've got depicted the currency of Menegroth, one stater. That's a 10-gram gold coin. Menegroth will mint these and ship them back to Earth. They only become currency once they're on Earth in a vault, because then they can be traded with people on Earth for whatever Menegroth needs. The colonists themselves won't be exchanging these, they'll be exchanging tokens in their place. I'll briefly discuss the Martian society and culture. However, keep in mind, Menegroth's founders should keep centralized planning to a minimum and instead let each generation play a small role in building up their new culture. They should remember this famous quote by Thomas Paine, "There never did, there never will, and there never can exist a parliament or any description of men possessed of the right or the power of binding and controlling posterity to the end of time, or of commanding forever how the world shall be governed. Every age and generation must be as free to act for itself in all cases as the age and generations which preceded it." But even keeping this caution in mind, some social engineering is going to be necessary, even if unwanted, because Menegroth will need new laws and customs modeled on successful pioneering societies on Earth. The Republic of Menegroth should declare political independence immediately. By the terms of the Outer Space Treaty, no signatory nation can make or enforce a territorial claim in outer space. Menegroth will not be a signatory to this treaty. It will offer a reciprocal commitment to make no claims on Earth. Menegroth will encourage diplomatic recognition by offering free passage to Mars for anyone who serves as his or her country's ambassador. That way, perhaps 100 small countries will recognize Menegroth because that's the only way to get one of their astronauts to Mars. Menegroth will be governed by a weekly assembly of all citizens aged 16 and older, with a president chosen to act as executive. He serves until resignation or removal by a vote of no confidence. The president can appoint whatever other officers he thinks are necessary as long as the assembly confirms them. Menegroth is going to use a Martian calendar, 12 months. Month lengths vary according to the seasons. 49 days in the shortest, 70 in the longest. Every year and every month of every year has a whole number of weeks. There are no common day or month names between Mars and Earth. There is in the Martian calendar. We don't going to call a month October. We're not going to call a day of the week Thursday, because that'll create confusion. It can't be October on Mars and April on Earth. Different month names, different day names. In addition to the seasons, colonists also need to follow the Earth-Mars synodic cycle of 25.5 Earth months. Each synod begins at conjunction. Launches have to happen during the first half of the synod, landings on both planets in the second half. In my count of synods, Synod 1 is the flyby of Mariner 4 in 1965. We're currently in Synod 27, which began on the 2nd of September of this year. Education is going to be important in Menegroth. Everyone's going to need detailed technical and scientific knowledge in order to survive on Mars. Everyone has to be a scientist. Children will begin grade school at age 7. They'll spend half the day in classrooms, the other half learning agriculture in the greenhouses. I think it's good to have children in the greenhouses. They'll be surrounded by the world of green things with other life forms in a planet where other life forms aren't very common. At 12, children move on to the Lyceum or the high school. Their study there will involve intense education in science, engineering, programming, and rhetoric. They'll also be ready to take on apprenticeships in the manufacturing trades. Music and athletics are also going to be an important part for the education of Menegroth's youth. Athletics especially. In low gravity of Mars, you're only going to develop your body to its full strength if you work hard to do so. Colonists will play racquetball because gives you a very good workout in a small and enclosed space. The main team sport will be basketball. Basketball on Mars will also be a great entertainment event to broadcast back to Earth. They're also going to have wrestling and swimming, both of which I think will be good sports because the low gravity isn't going to give you much of an advantage. Once you're in the water, you got to work just as hard as if you were back at home on Earth. In conclusion, Project Menegroth presents what I believe is a workable plan for building a 1,000-strong city-state on Mars. However, before you can build Menegroth, you have to have scientific explorations thoroughly map out the whole planet. You have to You have to basically go there and back again before you can go there to stay. That's the lesson Columbus learned the hard way. He left men in the New World on his first voyage. When he returned, no survivors. You also have to have a system of routine, safe, interplanetary space flight so that you can always rely on resupplies on schedule every sign-off. I believe the natural cave is going to provide the colonists with the best possible habitat, a large, spacious volume, a safe place to live and work. Political independence will be declared immediately, but in the end, only a great deal of discipline and hard work and building the best possible education system to raise up the next generation will be able to establish a lasting human presence on Mars. And that is my conclusion.
Okay. Questions?
I was puzzled by your conclusion that if you use solar, I assume electric power for your ground vehicles, that you were somehow limited to 40 kilometers a day of travel.
That was a fairly rough estimate. I said in my paper how many solar panels or how much area of solar panels you'd have to lay out. The reason it's so low is because I said in addition to your one pressurized rover with miners in it, you also have about a dozen semi-autonomous mining machines that they're basically going to be escorting. You have to every day take your solar panels out, lay them out in the sun, charge basically a dozen vehicles.
No, you don't. You charge up 500 kilometers before you leave, like I do with my Tesla every day, and you have pre-positioned solar power stations that are superchargers that accumulate power and transfer it.
Yeah, that's true. But with a Convoy, you don't have pre-position. You have to set it up every place you go.
You really think a Mars colony is going to allow Teslas? Okay. All right. I have a question for you. You have 45 hectares of agricultural land.
Yes.
Are these in the lava tube?
No, they're on the surface, natural lighted.
They are lit by natural light.
Yes, lighting them artificially would take more power than you actually have.
Yeah, that's the point.
So, are you assuming that you find a lava tube that has a natural lake in it, or are you assuming that you create a lake by bringing in enough ice?
No, you have to create a lake by bringing enough ice. That's my assumption.
Any other questions?
I like the Silmarillion reference. My question is, how would you verify that the lava tube is strong enough to be pressurized?
Well, you'd have to start with test trials. So first thing you want to set off perhaps smoke bombs inside, see where the smoke comes out on the surface, so you see where you have to seal. They already do that to find entrances to caves on Earth. And then you're going to want to seal off any weak points with concrete and then try to pressurize it. And if you detect leaks, you got to go and seal off the leaks. It might be trial and error. You might attempt to seal one cave and it doesn't work and you have to move on to a different cave.
Any other questions? If not, let's give a big round of appreciation for this presenter.